Here's problem 7:16. Two equal masses are raised at constant velocity by ropes that run over pulleys as shown below. Mass B is raised twice as fast as mass A. The magnitudes of the forces are F sub A and F sub B, while the power supplied is respectively P sub A and P sub B. Which statement is correct? Well, there's a few key words here. We're told that we have equal masses, so we're going to have equal weight. So the weight of A is going to equal the weight of B. Nice to know. And then we're told that it's pulled at constant velocity, which means that the net force on both masses will be 0. And that means that the force that we're pulling up with on A is exactly equal to its weight. And same thing with the force that we're pulling up with on B, so that the net force in the vertical direction will be 0, so that we can have constant velocity. Okay, so since the weights are equal and the net force is 0, these two forces that are pulling up should be equal. So F sub A is equal to F sub B. We can make that statement. We're told that mass B is raised twice as fast as mass A, so the velocity of B is equal to 2 times the velocity of A. As we're going up in a vertical direction, we have, here's the velocity of B, here's the velocity of A. Well, we know that power is equal to the dot product between the force and the velocity. So in this case, power A is going to equal force A, velocity A, and power B is going to equal force B, velocity B. So, since power B is equal to force B, velocity B, we can say since force B is equal to force A, this is equal to force A, and the velocity of B is twice the velocity of A, so let's substitute that in. So this is equal to 2 times the force of A, velocity A, or we could say 2 times the power of A. So the power of B is twice the power of A, mainly because its velocity is twice as much. It's got the same force, but twice the velocity. Another way to think about it is that power is work per time, and if it's going twice the velocity, if you do the same work, you're going to do it in half the time, so the power would be twice as much if you look at the problem in that way. That's just a different way about thinking about it, but this is a way to prove it. Power of B is equal to twice the power of A.